Good morning and happy remote learning day. So today, Monday, February 1st, and tomorrow, Tuesday, February 2nd, we are going to be doing asynchronous lessons just like we did on Friday. And then Wednesday will be office hours, and then I'll probably be back in the building on Thursday, and we will be doing live lessons again. Okay, so take a minute and answer today's attendance question. I would say pause the video, but quite frankly, I can't force you to pause the video. But it would be super cool if you paused the video right now and thought about this problem and tried it on your own. But if you want to keep watching and not pause, what are you going to do? Okay, so when I first told you about functions, I gave you this notation here, like f of x equals x squared. Now, I was looking over your test on functions. You actually don't need to know this notation, but you're going to need to know it next year for algebra, so I think it's pretty cool that I'm showing it to you now anyway. So if you recall, the number inside the parentheses, or whatever value is inside the parentheses, is the input. And over here is like the rule. This is what you do to it. So you input x, you plug in some number x, and what do you do to it? Well, the rule is you take x and you square it, or you take x and you multiply it by itself. So if we wanted to do f of -5, let's see here. Let's say we wanted to do f of -5. Well, you would take whatever the input is, in this case -5, and you would square it. Now, unfortunately, you could get into a little bit of trouble on this if you did it on the calculator. If you did this on the calculator, -5 squared, it might say the answer is -25, but unfortunately that's wrong. And the reason that's wrong is when you're doing order of operations like this, what this really means is take the number 5, square it, and then multiply by a -1, because you would do exponents first before multiplication. What we really want to do to evaluate this is take the number -5. So I'm going to put this in parentheses to show that I'm taking the number 5 and squaring it, or multiplying it by itself. What does that mean? That means -5 times -5. A negative times a negative is a positive, and therefore our answer is 25. So if you got 25, you were correct. Okay, so today we're going to be talking about what's a linear function and what is a nonlinear function. So let's look at the example that we did in the attendance question, which was f of x equals x squared. Now, if you remember, I was saying you probably don't need to know this notation, so I think for simplicity's sake, I'm just going to say y equals x squared. And let's compare it to another function that says y equals 2x. And so we're going to try to answer this question, what is a linear function and what is a nonlinear function? Now, you're probably saying, but Mr. Holland, how am I supposed to know what's a linear function and what's a nonlinear function when you didn't even tell me what that was? Well, I'm not going to tell you what it is, but we're going to try to figure it out together. And I want you to look at this word linear, and I want you to think if you can see any word in there that makes sense. So look at this word linear, and then over here we have nonlinear. And as we're graphing these functions, I want you to try to look at the word linear. What word do you see in there? What do you see in the word linear, and how does that apply here? So let's do y equals x squared. So all this means is you take an input, an x value, and you square it, and you get the output. So let's plug in some numbers like -2, -1, 0, 1, and 2. So let's square these. So let's plug in -2. -2, you square it, you get out 4. -2 times -2 is +4. You plug in -1. -1 squared is 1, because that's just -1 times -1. Remember, a negative times a negative is a positive. 0 squared is 0, 1 squared is 1, 2 squared is 4. So So now we have a set of points, x and y, and let's graph them. So our first point is -2, 4. So we're going to go -2 and then up 1, 2, 3, 4. Then -1, 1. Then 0, 0. Then 1, 1. And then 2, 4. And I'm going to connect these as best I can. Okay, it looks something like that. Okay, so keep your eye on that function. I'm going to just move this over slightly. I'm going to try to. Okay, that's pretty good. And now y equals 2x, we're going to do, oh, hold on one second. Okay, we're going to do another table here, and let's use the same x values. So let's use x is -2, -1, 0, 1, 2. Now, this function 2x means you just double it. -2 times 2 is -4. -1 times 2 is -2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 2 is 4. So again, we have our points. -2, -1, 2, 3, 4. -1, -2, 0, 0, 1, 2, and 2, 4. And then just like I did with the last one, I'm going to connect these, and that's what our graph looks like. You know, actually, I can probably connect those better. Let me do this. This is a better way to connect them. There you go. That's better. Okay. Okay, so now we're looking at the graphs of these two functions. And remember, we had this original question, which one's linear and which one is nonlinear? And again, I didn't even tell you what the word linear means or what the word nonlinear means, but I did ask you to look at linear and see if you can find a word in there that might give you a clue as to what linear means. And hopefully you've looked at that, and maybe you've seen that it has the word in there, line. And over here, nonlinear means non-line, a function that's not a line. So when we look at these two graphs here, this first graph, is that a straight line? This is not a straight line. So then we would say this function is non-linear. And then this function over here, because it is a straight line, remember the word linear, it means the graph is a line. So therefore this one is linear. Now, one thing that we're going to talk about in a minute, and it's easy to see on a graph if a function's linear because, well, you can just look at it and see if it's a line. But another important thing to remember about lines and about linear functions is that the rate of change is always the same. Like, you could pick any 2 points. Like, let's say I picked this point here and this point here. I could calculate the rate of change. Remember, rate of change is the same as slope, as change in y over change in x, or rise over run. So this one goes up 2 and over 1. 2 over 1 is 2. Well, what if I picked what if I picked 2 totally different points? For example, let's say I picked this point here. Let's say I kept this point here, but now I picked this point up here, right? I'm claiming that the rate of change is always going to be 2. So let's count how much we go up and how much we go over, or change in y over change in x. We go up 1, 2, 3, 4, 5, 6, up 6, and over 1, 2, 3, 6 over 3. Now the numbers are different, right? In the first case, it was 2 over 1. In this case, it's 6 over 3. But guess what, folks? 6 over 3 is the same as 2 over 1. 6 over 3 is 2 over 1. This one equals 2, and this one equals 2. So we've actually learned 2 ways to determine if a function is linear. One is you can look at the graph, and if it's a straight line, well, then it's linear. Another way that we also learned, and it kind of follows from this, is that if the rate of change is constant, meaning if the rate of change is always the same no matter what 2 points you pick, then it's linear. Okay, so what I'm going to do here is I'm going to turn it over to another video that actually does an incredible job of explaining how you can figure out if a function is linear from a table of values. So let's just leave it off with remembering that if you want to find out if a function is linear from a graph, well, just look at it. Is it a line? Then it's linear. But from a table of values, or from a graph too, you could say if the rate of change between any 2 points is constant, if the rate of change is always the same, then it's linear. Okay, so now I want you to go ahead and click on the second video, and she's going to do a great job of explaining how to check that. I will see you guys tomorrow.